Hello everyone, my name is Arnold Morales, and well, today I'm going to present this work. So, as a brief introduction, yeah, as a brief introduction, we know that with the growth of uh, content on various platforms, the multimodal information and data has also increased. So, and some portion of this multimodal information and content may consist on questionable content. So, well, we try to approach this problem of detecting this type of content with multimodal attention-based models. Mhm. So here we have a brief picture of different ways of dealing with this type of information, multimodal information. Among we have early fusion, such as zooming or concatenating these representations, also the use of cross-attention mechanism, and hierarchical attention, which basically consists, or well, maybe one stream to multi-stream, or multi-stream to one stream, processing each input by a different transformer layer. Okay. Uh, well, as a reference model, we have this one, a CAP, which stands for Hierarchical Cross-Attention Model with Captions. It consists on 4 blocks. The first one is a feature encoding block to encode the 3 different modalities that we are working with. Also the hierarchical cross-attention mechanism and the classification block. Well, the hierarchical cross-attention mechanism aims to capture intermodality representation using cross-attention mechanism to enhance representation of different modalities. And well, since we want uh, to explore different ways of weighting this type of information, doing so hierarchically may be not the best way to do this. So instead, we propose this parallel cross-attention, which aims to learn different representation of the main modality with the aid of the others. So basically, we have 2 different representations of the same modality, and then we try to merge them the best possible. And for this, well, for the fusion of these different representations, we propose the use of, well, concatenating and summing this representation, but also the use of GMU model, which basically consists on, well, this model aims to learn the relevant parts of each of the outputs and try to merge them only, well, only the most relevant aspects of these outputs. Well, that's our proposal. For our experiments, we are considering questionable content as comic mischief content. So we use this data set, which consists on 2 tasks, binary and multitask classification, in which we have 4 categories, which are, well, gory, slapstick, mature, and sarcasm. And also, well, as it's a task of classification, we used F1 score and macro F1 score for classification metrics. And well, in the results, we obtained a good results using our model, parallel cross-attention, also with the use of GMU fusion in binary tasks and also in multitask classification. And well, in macro F1, we obtained a good performance also. And well, we can see that it's learning, well, it's learning important information and also relevant information in different aspects. So, well, to conclude, we know, well, these results suggest us that our mechanism is working well and outperform the hierarchical cross-attention in the detection of this comic mischief content. And also the use of GMU outperform the standard approaches for the fusion of multimodal attention mechanism. And well, as a future work, we want to testing this model in different data sets, and also a deeper analysis on this model, specifically with the GMU fusion, to well, to make sure that is learning only the most relevant aspects of this information. Well, thank you. I don't know if you have questions.
Hello. Okay. Hi. Thank you for your presentation. My question is just from what I understood, your model. I mean, you're focusing on this task of questionable content detection, but classification. But it doesn't mean that can it be applied to other multimodal classification tasks? I guess that would be my question. And have you tried something like that? Because it doesn't seem that there is anything specific to the task. It's just like you did like the architecture in a way that, oh, let's see if we can explore the relationships between the modalities better. So I would expect that this would benefit other tasks as well.
Yeah, we are exploring different tasks such as, well, I don't know if you know Multibench toolkit, which are different datasets, multimodal datasets, and we are working with it and also with this model. So yeah, it's well, we are working with it.
Okay.
Yeah.
First of all, really nice paper. I think it was quite complex for and in a larger conversation, I'm sure there would be more details. But my question is more to the side of scalability. This dataset was quite small. Do you think this scales to larger datasets like millions, or is something that would need like a lot of resources to go that far?
Well, I think we will need more resources because with large datasets maybe not be as good as this one, but yeah, I think it is.
Thank you. You were talking in the beginning about detecting harmful content, but then I think the task was framed as classification. So what do you see? How do you see the link between classifying videos to kinds of humor and detecting harmful content? And just in general, more between classification and detection, what would need to change in your system, do you think, to detect harmful content instead of classifying kinds of humor?
Well, we are working in, well, questionable content classification already. And well, the definition of questionable content is not easy to, well, it's not easy to define it. So we took the definition as comic mischief content, and also we classify this type of content. Yeah.
So you classify into categories, and some are harmful or questionable, and others are not. That's the point.
Yeah, something.
Okay, thank you.
Let's give the speaker another applause. Thank you very much. All right.